Hello. I'm going to go over some of these problems that were given for review, where this is an old exam from Mac 101, and this is advanced C++ 125. You should be able to pass this exam. So I've selected some problems for us to go over.
Don't trip. Oh.
I've used Visual Studio.
Get the meat. Don't worry about it. It feels like a triple.
And I'll go over some of the problems. One problem. I did a cut and paste as comments. Write a function that accepts three doubles that are variables A, B, and C as input and returns a middle value of the three, not the value of A. Excuse me, B, not B's value. But if these are three numbers, a magnitude, return the middle magnitude. And we're assuming all values are unique, so we don't have to ask about equality. So here's a draft attempt. That works. This is very adequate. One, nice name, middle. Three variables. Here, A, B, C are suggested as names, so I'm not going to be shy. I'm just going to make my life easy and write A, B, C here. I think it also makes it easier for your professor who's grading this thing. Next, I'll say, well, what do I know about A, B, and C? They're three numbers, and I want the middle value. Well, if B is in the middle, then it'll be less than A and greater than B. So if A is greater than B and B is greater than C, return B. Voila. Well, what if that's not the case? Well, it could be that B is still in the middle. So C could be greater than B and B could be greater than A. Thus, it is in the middle. Return B. Here we have A could be in the middle, and there are two cases for A in the middle, just like B in the middle. B could be the largest, A could be the smallest, with A in the middle. It could be that C is larger than A, but A is larger than B. That again places A in the middle. Now it could be written on one line, such as this, where I say C is in the middle if A is bigger than C and C is bigger than B, or B is greater than C and C is greater than A. Return C. You could write 3 lines of code like this, or you could write it in pairs. They're very acceptable. Next, after you write this code at home, on the exam you don't necessarily have this opportunity, but you can create a test code. So here I place the answer in the middle, and it does print up in the middle. Here I placed it, here I placed it at the first item. Typo. Here, so it should be 34 is in the middle, 34 is in the middle, and 34 again is the middle number. So this should output 34 each time. And if I compile and run this program, 34, 34, 34. We'll go through the rest of this shortly.
A whole other dimension.
Another problem, select problem, is to write a function that computes m times n using only addition. I'm not going to use recursion here. I'm going to use iteration. Make life simple. Only positive integers are considered. So we have 2 times 3. It's 2 plus 2 plus 2. 2 3 times. So here I turn around. I call the function mult, or the word multiply, something reasonable. I called it n and m up here, so I'm going to use the same variable names here. Right off the bat, I'm going to make my life easier. I'm going to say, well, if n is 0 or m is 0, then I know the answer. Right away is 0. Well, what if I don't know the answer? I have to go through a loop where I add things up. Normally, I use for loops. Here, I'm using a while loop just to be different. So here I'm starting off, I'm going to look at m. I could have looked at n, but I'm looking at m from my iteration. So I say, well, is it greater than 0? Obviously, since we got past this, But we asked the question anyway, is it greater than 0? If yes, come in here, take n, and add it to product. Notice up here, in this case n would be 2, plus 2, plus 2, 3 times. So here, I add it to product once, and then I subtract 1 from m, and I look, do I have to do it again? And I stay in this loop, and m gets smaller and smaller until it's 0. When it's 0, product as my total. I'd like to test this after writing this code. I go up here, and here I did some multiplication tests. 10 times 0, 0 times 10, 3 times 10, 10 times 3, 0 times 0. Not the most exhaustive test, but probably pretty adequate. Compile and run this, and you see I get 10 times 0, 0, 0 times 10, 0, 3 times 10, 30, 10 times 3 is 30, 0 times 0, 0. Moving on down, one of the other questions was to write a function to add the first n elements of an integer array. Notice very carefully, read like software engineers, you're like lawyers for technology. The first n elements of an integer array called A, and return the sum of those elements. It asks you also to state the precondition for this to work correctly. All right. So here I called it add n. You give me an array called A, call it anything you like, but I called it A here. And n, the size. My preconditions are A cannot be pointing to, it cannot be a null pointer. Spell that right. A cannot be null. That means it has to point or reference an actual array. And n, it's got to be greater than 0. Otherwise, we don't have an array. So they both must be true. That's the relationship. We also realized that n, we need to add up the sum, the n first elements of A. And n must be less than or equal to the actual array size. So here I have sum. I start off at 0. And I simply walk through the array one element at a time using I, and add up all the values in sum and return sum. I'm not sure I tested that up here, but we could. We create an array, integer, I'll call it x. I'll put in 3 elements. I'll put in 4 elements there. What the heck, 4. And I'll let the compiler set it up for me. Add up 1, 1, 1, whoops, 1, 1, if I could hit a comma, 1, 10. Now I have 1, 2, 3, 4, 5, make it 5. 5 elements. Name of my function was add n, so I'll say, quote, add n. And I will say add n, and let's see, x is the name of the array, and I'm not going to add up all the numbers. I'm just going to add up 4. So I should get the answer 4, because there's only 4 numbers here, 1, 2, 3, 4, and I put 1 to make my life easy. So if I compile and run this, I see I have an array called x with these numbers, and if I add them up, it's 4. If I really want to test it some more, I'll change that to a 2. Compile and run it. And now 2, 1, 1, 1 is 5. We get the add n is 5. Moving on down to another question.
Musket.
Notice also in this question I provided a section of comment called usage example. It's not uncommon for programmers or software engineers when writing complex code to give a quick example right above the function if it's possible.
This guy, he's never played like Leland.
Next, write a function that returns the position of the first match of a search argument called v. It's basically the argument is a number, v, and it's an array of numbers. The array is called a, and how long is it? Its length, L. If you don't find it, return a -1. And you're told that the function's header must match this. You have no choice. That has got to be the API. Another term for this header is an API, Application Program Interface. So here I have my parameters, my list A, the number of elements in A, and the item I'm looking for that I want to count. I want to find a position of, not count, excuse me. So I assume A is not a null pointer and n is not equal to 0. In fact, it must be greater than 0, something stronger. I can't allow a negative number in there. Simple fun-loving for loop says, okay, let's go through the list A looking for V. Right here it says, look at A of I, does it equal V? If it is, bingo, tell me where you found it. Tell me the position I. If this loop ends and you don't return, then you get to this line of code and you say, I haven't found it with a -1. Might be nicer if I was production, moving these things out so other programmers or software engineers can see it in the future. Next piece of code, write a function. Again, a header is given. Now this one's a more complex header. The function is called replacement. There's a key, there's a replacement value, it's a list of data items, and size n. How do you figure that out? I can't figure it out by reading this. There's no way. The only thing I know is this is going to be my API. That's all I know. I have an idea with the word replacement. It means something. Key says, that's the thing I'm looking for, the key. And R actually means the thing I'm going to replace it with. So I read this carefully, whose purpose is to search a given list. There's my list. To find and replace all occurrences of key with the value R. If no replacements were made, it should return 0. Otherwise, it should return the count of replacements made. Now, to help us understand this piece of code, there's some examples that says, I don't know how you're going to build this thing called replacement, but this is what I need you to do. Maybe these are colors on a map, and I want to replace the color number 23 with the number 99, which means something else. I don't know. So here's my initial array, 1, 2, 3, 4, 5 items. I should probably put a 5 in there so it's unambiguous. So I see there's 5, there's my 5. And if I look up here, there's my n, which is going to be 5. Replace, look for the number 23 and put in 99. And it tells me after it runs, it will find 3 23s, 1, 2, 3, and replace it with 99, 99, 99, 99. Now here's the code. Notice the header is exactly what's required of me. How I write this is not specified. How it works is specified. The insides are up to your engineering creativity. So I start off with a counter, and no elements were replaced. And then I walk through the loop. I walk through the array, starting at item 0, go all the way up to the last item. Take a look at my key, compare it to the list of numbers. If there's a match, add 1 to the count, haha, I found one. And then take R and move it into that item to replace it. When I'm done, I simply return the count. And also what happens is the data in this list of integers will be replaced. So I like to test that. I go up here. There's my test procedure. It's a little more involved now. What I end up using to make my life easy, I use a function called display that shows me an array and everything in it. So here I set up a giant test array. Here I calculate the size of the array, or let the compiler do it for me. This is done at compile time. Runtime means when the computer program is actually executing. This is done while the program is being built or translated. I then display the data. So I see that this is correct. I like to see things. Then I say find all the 23s and replace them with 99. Find all the 23s, replace them with 99 in the array A, from the beginning to end, and then display the result. If I build and run this program, so I have 23, 23, 55, 8, 23, 5, 5. Well, you can read this yourself. But when I'm done, you'll see all the 23s on the next are 99s. Let's go look at the display. The display function, which is useful, I write that down. Write a function that prints all the elements with no more than 10 integers displayed per line. That means 10 columns. Give me the array of integers. Tell me how many there are. Start at the beginning. Print one out at a time. Leave a space in between. And notice I got a little fancy here. It's not required on the test to be fancy. But I said set the width to 4. Keeps the spacing even. Then I turned around and said, take a look at what number you're printing. The 6th, the 5th, the 20th, the 30th, which number? Divided by the number of columns you want. Notice this is asking for the remainder. If the remainder is 1 less, for example, if you divide by 10, which is what we wanted, 10, the remainder will be 0 through 9. 0 through 9 is a count of 10. So it goes 0, when you first started, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that means you printed 10 things out when the remainder is 9, so it simply skips a line. If the remainder is not 9, do not skip a line. This could look very nice if I wanted to print in columns of 5. Change that to a 5. And if you look here, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2. The max will be 5. It'll automatically adjust if I want this to be 3s.
I think you broke my card with that.
Look how nicely and dynamically this thing adjusts. It shows me my arrays very, very nicely. Now it actually looks like a matrix. This is a useful technique to learn this. There's even a sneaky way of doing it. I could get rid of both of these lines and replace it with this thing. Although I did forget to put in set W. Let's do it just for the heck of it. Slash 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 slash. This, whoops, and I'm going to cut this out and plop it right there. And if this runs correctly,
Yeah, you just keep getting those.
we should get the same result, or else I have a typo. No.
I'm pretty sure you got like 3 so far.
There it is.
You should be quite
This
happy.
one line,
Stack them on one person.
the tricky method, replaces these 2 lines here. They do the same thing. And this skips a line at the end to make it look good.
Hey, check that out.
One of the next questions was to write a program that computes the Fibonacci sequence recursively. There's your standard function here. This one's a little trickier. This is to write it iteratively. Again, I take a shortcut, and otherwise I build my Fibonacci's by exchanging variables over here. To test this, Control Alternate, and you see Fibonacci Technique 1, Fibonacci Technique 2. How did I test it? If we go all the way up to here,
Yeah, it's Tuesday's your final, right?
you will see there is where I'm testing it. So notice when you build functions, you come up with some sort of test procedure. Later in the semester, we'll look at the Fibonacci sequence again, and we'll look at it, what happens when you compute very, very large numbers. It takes a long time. All right, so I hope this is a helpful review before your
Because I'm not
midterm.